All right, so just a refresher. Yesterday we talked about polynomials. We talked about relative and absolute extrema. And just a reminder, the relative extrema can happen where a function changes from increasing to decreasing or decreasing to increasing. Where else can a local or relative extrema occur? At the endpoints. Don't forget about the endpoints. All right, and then absolute extrema, same thing. They can occur where the function is changing, increasing to decreasing, or decreasing, increasing, or they can occur at an endpoint also. All right, and then we talked about the points of inflection where the concavity changes. And so we're going to do this number 4 on the calculator, but I'm adding questions to it. Now to answer number 4, the question is, at what time is the number of cars in the parking lot changing from increasing to decreasing? You do not have to do all the things that I'm doing, but I just want to refresh your memory about it. So we're going to do different things. We're going to answer the question, where are the local extrema? And we're going to answer the question, what is the global minimum? All right, those are just extra questions I'm asking because I just want to remind you. All right, so the first thing we're going to do, we're only using this function between 0 and 3. And it gives the number of cars in the parking lot at time t hours. And so let's just go ahead and put that in the calculator. All right, so after you get that typed in, we're going to change the window a little bit. And so we're only looking from where t is 0 to 3. So what we're going to do is go to the window, and t is corresponding to x here. And so we're going to change that from 0 to 3. Now, the x scale, it just talks about like the tick marks. You don't ever have to change the scale if you don't want to. All right, now we're going to also change the y's. So right now, mine is set at -10 to 10. Yours might be something different. It doesn't matter. But does a negative number of cars in the parking lot make sense? No. All right, so I'm just going to look at the graph from 0 to 10 cars. Right, and that's obviously not quite enough. All right, so we're going to go back to the window. Which one of these things do you think I need to change? The y max bit. So if you were just guessing about how many cars were going to be in a parking lot, what would you guess? Just a number. Throw me a number out there. Okay. Still not quite enough. It's okay. There's no reason to stress. Oh, that's good. Yes. All right, So look at that for a second and see if you can find the local extrema, local max, local min. Oh, you skipped this little before. Okay, we can put it at the end. There you go. And we just want to know where. So what x would there be a local min? X's, I should say. There's two of them. Just a reminder, these two are endpoints. Would the endpoints be local minimum?
Yes.
Yeah. So x equals 0 and x equals 3. Don't forget about the endpoints. I did the same exact thing with my last class, and when they went to do their assignment, they forgot about the endpoints. So try not to forget about the endpoints. All right, now that max. The max is kind of obvious because it's the top of that hill. Now we have to find it. We can't just trace to find it because it won't be accurate to 3 decimal places. So do you guys remember how to do it? Second trace, good. And since we're finding a maximum, we're going to choose number 4. So second trace, number 4. You get this little flashing guy. We're going to move close to the maximum, but we're going to stay on the left side. And then we're going to hit enter. Move to the right side. Hit enter, and then enter one more time. All right, so the local max is going to occur when x is equal to 2.446. You technically could also, and it would be 100% right if you did 2.445, as long as you're accurate to 3 decimal places. All right, any questions? All right, that is also going to be where the global max is. I didn't put that as a question, but if it was a question, you would say the global maximum value is this 31.898 or 897 at that point. But I'm asking you, what is the global minimum? So, say it again.
0.
It's going to be at 0, yes. And to find the value at 0, probably the easiest thing to do is just go to the table. So the least amount of cars that are going to be in this parking lot from 0 to 3 hours is going to be 3 cars. All right, so please, please, please don't forget about the endpoints. And this is another thing that comes up in calculus. In calculus, students forget about the endpoints. So I'm going to say it a lot. People are still going to do it. It's okay. You can't remember everything. All right, so the real question for this is based on the model, at what time t does the number of cars in the parking lot change from increasing to decreasing? So I'm going to go back to the graph to answer that question. So what do you guys think?
2.
Yeah, the t value at that maximum, which is going to be at t equals 2.446 hours. All right. And I'm going to write the calculator steps for somebody who might not remember it from Algebra 2. And then it's second trace, and then it's 3 for the minimum and 4 for the maximum. Once you hit second trace, it's fairly obvious what you're going to do after that. Okay. I'm making up a question for the back. So on your assignment today, you'll be given a function, you're to draw a function that has this many points of inflection and this many local whatever. So I wanted to do one of those with you before I like set you out to do it on your own. So we're going to make up a function. It's going to be f of x. And f of x has 2 points of inflection. Three local extrema. And 1 global extremum. So it's just the singular and plural form of the word. It's kind of weird. You'll see them both. It's fine. All right. And one more thing that I don't even think I've mentioned the word domain all year, which is kind of weird that we're this far in and I haven't said it. But I'm going to say it today. Later we'll talk plenty about domain, so don't worry. But the domain of f is negative infinity to infinity. What do you think that means on the graph? It doesn't have to be an odd degree. But the arrows, you're going to have an arrow pointing left and you're going to have an arrow pointing right. So if you have negative, I think you were thinking about the range. It's okay. So we're going to have an arrow to the left and an arrow to the right. So let's do this drawing. Oh, yeah. Sorry. Thank you. We don't even need it anymore. All right, so you guys get to decide. We're going to have to change concavity twice. So do you guys want to start with concave up or concave down? Concave up. Okay, so here we go. We're concave up for a while. Then we're going to change. We're still concave up. Then we're going to change to concave down. So that's 1 point of inflection, about right here. All right, and then we have to be concave down. And then we have to change again. And then go back up. Now I drew that. There are other things that have to happen. Let's make sure they did. But those are my 2 points of inflection there. All right, I also needed 3 local extrema. So doing the 2 changes of concavity pretty much creates the 3 local extrema. So that is my 1, 2, 3. All right, now the only thing that if I just drew this, thinking about the concavity, I might have to do again, is that there's 1 global extremum, which means that these 2 should not be like perfectly lined up. Like one should be a little higher than the other. But it worked out for me that this is my 1 global. So I did all the things I needed to do. All right, so what questions do you guys have? All right, so I'm going to give you your assignment, and what are you not going to forget about when you're doing it? You're not going to forget about endpoints.